Okay, so good evening, everybody. I hope you guys are doing well with the COVID-19 spreading out. So I just want to let you guys know that we're gonna have another makeup class this week. Possibility will be on Thursday. And the final exam will be scheduled according to the timeline of the school. But I will check again which day. Okay, the method of examination would be online, and the details of this examination will be covered possibly on Thursday for you to go and read what we have learned so far. Okay. Hope everyone can hear me. Okay. If it's because I cannot find my earphone, I lost it somewhere. So I'm speaking through the normal speaker and microphone from my computer. Okay, so we are about to discuss on another topic in recent classes that we gone through. We mentioned about several aspects of intersections, and now we go to the some sections, the stress section, and under the conditions of uninterrupted flow and interrupted flow. So both definitions of uninterrupted flow and interrupted flow, everyone should understand, you know, what are the differences between those two terms. And what I mean can be found in many resources. I want to, before I go into the class note that I sent to you, I think this video clip is one of the information topics that I'm going to show you. I want to let you watch this. Share screen. Okay. As we learn about the highways and freeways and many sections of the road, one of the basic things that you should know is about the highway capacity and their level services. So you should at least having the concept in your mind. What are they, and why we need to understand some of these concepts. And this graphic that is on YouTube is a very useful way to let you see from the DOT, from Department of Transportation aspect, and I want you to study a little bit from here. how should this thing? Share style, okay. Can you hear the voice from the video?
ได้ค่ะ
Maybe a little old, okay? But
Highway transportation is one of the most talked about issues in America today. With the emergence of the automobile as our primary mode of transportation, an ever-changing, ever-growing network of highways has reshaped the face of our national terrain.
okay, what are you seeing is about freeways and highways in United States. In many states, they developed different level of operations, but all of them require to meet the standards and the requirement from Federal Highway Administration, or FHWA, okay, FHWA. So Department of Transport of each state will follow its standards, and they may have a different operation scheme, but slightly very different. For example, they may have their own signs, they may have their own kind of unique devices, but everything, you know, conform with the standard. Anyhow, what you are looking is the characteristic of different road sections and different road types. Okay, let's start with the beginning, which they're gonna give you a little bit of overview of the American highway system. Okay, I go back a little bit.
Highway transportation is one of the most talked about issues in America today. With the emergence of the automobile as our primary mode of transportation, an ever-changing, ever-growing network of highways has reshaped the face of our national terrain. Yet few of us really understand how and why roads are designed. Roadways are built and rebuilt using complex engineering criteria, data, and analysis to determine what type of facility best meets the needs of the location it will serve. Roadway design is founded upon one simple premise: improve traffic flow and safety for the people who will be using the highways. Applying basic concepts of traffic engineering, the transportation engineer interprets such factors as traffic volume, different speeds, and causes of delays to help formulate the appropriate design. The presentation you are about to see will attempt to provide an overview of the key elements in highway design and analysis. Based on the 1985 Highway Capacity Manual, this tape illustrates some fundamental concepts and definitions used to analyze traffic flow and capacity of freeways, arterial roads, and intersections. These analyses are the groundwork for subsequent design that will upgrade the capacity and condition of our roads. The study of traffic flow and operations classifies roadways or facilities by two major categories: uninterrupted flow, such as freeways or tollways; interrupted flow, such as signalized intersections or toll plazas. Capacity of a roadway is the maximum number of vehicles that can be accommodated by any highway facility, such as a 2-lane, 4-lane, multi-lane freeway, ramp, or intersection. Capacity is also defined by the maximum volume of vehicles per hour that pass through a section of road. Level of service is a qualitative measure used to describe the characteristics of traffic flow. The level of service describes the operating conditions within a traffic stream or the perception of same by motorists and/or passengers. Level of service, or LOS, is influenced by several factors: speed and travel time, freedom to maneuver, traffic interruptions, comfort and convenience, delay and safety.
Okay, five basic attributes: speed and travel time, freedom to maneuver, traffic interruptions, comfort and convenience, and delay and safety are something that gonna contribute to the flow rate, okay, which imply that if these five criteria are met, the maximum capacity of that section of the road will be met. Okay.
The highway engineer bases the level of service calculations on features that define an ideal highway, even though actual highway conditions may vary from those standards. Those ideal features are 12-foot minimum lane width, 6-foot minimum shoulder width, the traffic stream consists of passenger cars only, all drivers are frequent travelers on the roadway and are familiar with its conditions. The highway was designed for speeds of 70 miles per hour. There are 6 levels of service ranging from A to F. Level A is free flow and low traffic density and is the most desirable. On the other hand, level F is forced flow. Its volume exceeds road capacity, resulting in complete congestion. Let's look at examples of levels A, C, and F. Level of service A consists of low traffic density and free flow operation. The average travel speed is 60 miles per hour. The ideal volume is up to 700 passenger cars per hour per lane. Level of service C has some restrictions in flow due to a higher volume, but it is stable. Slight increases in the volume of traffic will cause substantial reductions in speed. The ideal volume for level C is no more than 1,550 passenger cars per hour per lane. In level of service F, the operation has completely broken down. Vehicles are spaced bumper to bumper. Traffic flow has now become totally unstable. The traffic volume at level F is between 0 and 2,000 passenger cars per hour per lane at best. A freeway is a road without intersections. All freeway entrances and exits take place at interchanges. The ideal capacity of freeways is 2,000 passenger cars per hour per lane. A 4-lane freeway, for example, will have a capacity of 8,000 vehicles per hour per lane. In actual conditions, the total volume that can pass through a given section of a freeway is influenced by several parameters: number of lanes, width of lanes, distance to obstruction on the shoulders, driver familiarity with the road, the percentage of heavy vehicles in the traffic stream. All of these factors reduce the ideal volume to a real volume under a given set of conditions. The most significant impact on the traffic flow and capacity is generally the percentage of heavy trucks on the road. Weaving.
Okay, so they discussed about basic freeway section, and now they changed to the weaving section. Okay, now you will see this is called weaving, what you are seeing here.
Is one of the most complicated phenomena of traffic flow. It is defined as the crossing of 2 or more traffic streams traveling in the same general direction along a significant length of highway without the aid of traffic control devices, signals, or stop signs. Put simply, it means changing lanes within a section of a limited length. Weaving most commonly occurs when traffic moves into a merge area followed immediately by a diverge area. Because of intense lane changing in weaving areas, traffic is subject to more turbulence than normally found on basic highway sections. This turbulence presents special operational problems and design requirements. Ramps are defined as the length of roadway connecting two highway facilities. Studies of ramp roadways and freeway entrances are based on special procedures which differ from standard highway analysis. The junction of the ramp with the cross street or with the street at the end of the ramp is usually a signalized or unsignalized intersection. Sometimes it is of interest to the highway engineer to determine the volume which can be accommodated by a given ramp junction. The maximum volume at level of service E that can be accommodated by a ramp junction is 2,000 passenger cars per hour. At a moderate level of service C, the possible volume is about 1,450 passenger cars per hour for the merge and 1,500 passenger cars per hour for the diverge. The study of a freeway system integrates analysis of basic freeway sections and characteristics, such as sections without entrances and exits, weaving sections, and merging and diverging areas.
So merging and diverging areas mostly happen near the ramps. So there are two types of ramps, on-ramp and off-ramp, okay? So if we talk about on-ramp, is involved with merging, okay? If we talk about off-ramp, we will talk about diverging.
Several factors can affect freeway operations in general and freeway systems in particular. The analysis must take into account the characteristics of a continuous longer freeway facility, not just an isolated section. Freeway surveillance and control. The objective of freeway surveillance and control is to maintain traffic flow at or near capacity and to minimize the impact of breakdown conditions. Impact of work zones. The roadway system needs to maintain a continuous reconstruction, rehabilitation, and maintenance program in order to keep it in good operating condition. The engineer needs to know the impact of a construction project on the traffic flow. The capacity of work zones predicts the decline in volume caused by lane restrictions during freeway reconstruction. The reduction in work zone capacity is greater than the relative reduction in the number of lanes. On multi-lane highways,
Okay, they talk about freeway, they talk about on-ramp, off-ramp, and now they change to multi-lane highways. Okay, so you have to see some different configurations of facilities here.
the flow is normally uninterrupted. For the flow to be considered uninterrupted, a minimum of 2 miles between signals is required. Closer spacing classifies the route as an arterial road. Speed on multi-lane highways is more sensitive to the volume than freeway speed. Two-lane highways differ significantly from other roads. The basic operational problem is the formation of so-called platoons behind slow-moving vehicles, typically trucks. Opportunities to pass may be restricted by opposing traffic and/or by limited sight distance. Another important factor is the friction which exists between the two lanes, since each lane is closely affected by traffic in the other. Therefore, total flow in both directions must be analyzed. The ideal capacity of two-lane highways has been established at 2,800 passenger cars per hour for both directions. 5 basic parameters determine actual capacity of two-lane highways: the percentage of no passing zones in the road, type of terrain, such as level, rolling or mountainous, or grade of road, percentage of heavy vehicles in the traffic stream, the directional distribution of traffic traveling in each direction, the width of the lane, and the shoulders. The level of service measurement for two-lane highways is the percentage of time delay. This is defined as the percentage of total travel time during which a driver in a platoon is behind slow-moving vehicles and is unable to pass. For example, at level of service A, a driver would travel behind a truck for 30% of the time. The congestion and delay at signalized intersections have a significant effect on most drivers. People who travel to school, people who travel to and from work, people who travel to shopping or social events. Analysis of signalized intersections is based on the most frequently used movements of the intersection. It focuses on lanes or groups of lanes which control the requirements for green time allocation. The average stop delay of a vehicle at an intersection during a 15-minute period serves as a criterion for the intersection's level of service. For example, during a level of service D, the stop time delay of vehicles stopped at a light would wait would be approximately 40 seconds or less. These delays are highly dependent on the quality of the signal progression, the length of the signal cycle, the green times, and the volume to capacity ratio. The operation of signalized intersections is affected by a wide range of variables. Generally, they fall into three classes: traffic characteristics, roadway configuration, type of signal control. Unsignalized intersections are usually controlled by stop or yield signs. These intersections are commonly analyzed by the capacity in operation, that is, by calculating available capacities, delays, and average length of a line of traffic stopped at the intersection. At unsignalized intersections, the right-of-way is always given to the major street. Drivers on the minor street must let the main street drivers pass before merging into, turning onto, or crossing the main street traffic flow. Analysis of unsignalized intersections is based on the acceptance of space interval between main street vehicles and drivers on the side street. The driver on the minor street evaluates the interval and accepts it or rejects it. If the interval is accepted, the driver pulls onto the main street. If it is rejected, the driver waits to evaluate the next gap interval. A left turn lane is important to the safety and service of unsignalized intersections. A road with left turn lanes into supermarkets, shopping strips, or developments normally has a better safety record and reduced delays and interruptions for through vehicles. Spacing of signals at less than 2 miles apart qualifies a major road as an urban or suburban arterial. Because of traffic signal cycles on these highways, vehicles often travel in platoons. The quality of operation is controlled primarily by two factors: signal coordination quality, level of service at individual intersections along the highway. Since signals control vehicle flow, the capacity of arterial streets depends on the capacity of its signalized intersections. Arterial level of service is based on the average travel speed for all through vehicles on the arterial under consideration. In addition, several other criteria come into play when planning a new facility or upgrading an existing one. Those criteria include number of signals per mile, speed limit, pedestrian interference, and roadside development. Arterials with many closely spaced signals may operate at a lower level of service than arterials with fewer signals. This suggests that closely spaced intersections may have a negative effect on traffic flow, and special design measures, such as improved coordination between signals, may be needed. Roads are a critical part of the infrastructure that supports growth and land development. Over the last decade, we have witnessed increased citizen concern about roadway construction, placement, and effect on the community. Citizens play an active role today in land rezonings and regulatory activity, issues which impact upon road development. A general understanding of transportation engineering concepts and definitions will help civic and political leaders better understand the rationale behind proposed roadway design and to make more informed decisions about the highway infrastructure.
Okay. If you want to repeat those that clip, you can search it from YouTube. You can search for highway capacity and level of service to watch it again. I cannot find one that has a comprehensive information about what they want to give you the information about the different of the definitions of highway, freeway, those kind of things. I thought just only this one, which quite comprehensive. The movies I think is made since like maybe 15 years ago or 20 years ago. It's quite old, and they've been using helicopter rather than drone. I think this if somebody can do this in this kind of thing, I think it's going to be good for students and for others to understand the concept of freeway, highways, intersections, and those kind of things. Okay. I'll be back in a minute. I'll go to the bathroom real quick. Okay,ครับ. Okay, sorry, I'm gonna convert it for you right now. Just a sec. Save as print. Okay. The whole. This one.ขอบคุณที่แจ้งมานะครับว่าเปิดไม่ได้โอเค to PDF okay I need to pause real quick. Screen sharing. Okay. So if you remember, I sent you to download this file already, right? Traffic engineering, and I come back to chapter 13, which I'm gonna talk about today, about the fundamental concept of uninterrupted flow. Okay. Chapter 13. Okay. I think the purpose of this chapter to let you guys understand various objectives. First, to understand about the meaning of the capacity, and this, like I said, is the heart of the transportation issues. Why the capacity is the heart of transportation issues? Can you guys can guess? ความจุของถนนความจุของทางหลวงทำไมถึงเป็นปัญหาสำคัญของระบบการขนส่ง Anybody can guess?เป็นภาษาไทยก็ได้นะครับ
ช้ในการดีไซน์หรือเปล่าครับ
ใช้ในการดีไซน์ใช่ไหมส่วนหนึ่งถูกต้องครับ ใช้ในการดีไซน์ capacity ใช้ในการดีไซน์แน่นอนถูกต้องครับ แต่ว่าจาก wording อันแรกเนี่ย explain why capacity is the heart of transportation issue ใครพอจะเดาได้บ้างว่ามันเกี่ยวข้องกับอะไรในขณะในความหมายอันนี้ไกด์นิดหนึ่งก็ได้ยกตัวอย่างเนาะhow about condition of traffic in Bangkok what do you think I think if we don't mention about the past 2 years about before the COVID pandemic, what would you think about the condition of the traffic in Bangkok? Do you think roadways are enough for cars, the registered cars that use on the roadways in Bangkok, or is over? What do you think? ความจุพอเพียงไหมครับกับรถที่ใช้
ไม่พอครับ
รถติดใช่ไหม
ครับผม
and what if you think is about the congestion is about the traffic jam if you were the mayor of Bangkok is that easy for you to find a solution to relieve the traffic condition of Bangkok? Is it easy? What do you think they are doing right now? They cannot build more roads, is that right? Road network have a limitation of the capacity. And you know that there are more cars, more vehicles than the road can support. So our Thai government try to build not just more road networks. We need more public transportation network. So they think that building sky train or subway would elevate the problem of heart of Bangkok, right? So in this meaning, we have another alternative to create more movement, the need of movement of people in Bangkok and surrounding areas such as Nonthaburi, Samut Prakan, Thonburi, and so on. So if you focus only the roadway capacity, it's not gonna reduce any traffic jam at all because there's no more land that they can build more road, and the road itself, you know, required to pay for several things such as land acquisitions if it's not available for authority to build it. So you need to buy more land, and the cost of the investment would be higher. So they developed the system called motorway or toll road, so that they can bring more money to, to build the road network. It's not easy gonna do that. So that's why we come up with the plan for public transportation, and we would like to, reduce the number of owners of the vehicles. So we don't want to have more vehicles on the road. So one family, like in Singapore, they may have just one car. If they have more than that, they may not be able to afford other costs, such as parking costs, fuel costs, insurance costs, and the license costs. So this is the way to mitigate the problem. So anyway, capacity in transportation terms a wide range. So when we talk about increased capacity, it's not only talk about increased the capacity of roadway. Okay, easy to do it, yes, if there are, land availability. For example, you can, build more ring roads, or the road that, in the other word we call bypass. Many cities in Thailand got bypass. So they build more bypasses, but along the bypasses, there are more development around it, more buildings, more whatsoever. People start to move to bypass. So the city has been reformed by those new development too. However, it's not necessarily be a great way to make the road network become, better in that way. We try to, different methods to overcome the problem, which is but I just give you the example of what the condition in Bangkok. Anyway, because we learned about the highway engineering, you need to a little bit deep insight for the highway network. But as I mentioned earlier, long time in the past, that I just don't want you to only focus on highway. You need to look at more, out of the box too. Okay, define its capacity and level service concept and explain why capacity is not a fixed value. Okay, explain the differences between the service flow rates and service volumes. The relationship between V over C and level service. V over C is the volume per capacity ratio. Okay, it has a good meaning when compared. Okay, for example, if V is equivalent to C, so that means this ratio is equivalent to 1, right? C over C is 1. So 1 means the road is full of vehicles, right? So it's at the capacity already. If it's over capacity, what happened? Definitely, the speed and the flow cannot go as expected, as designed. So it's become level service F, which you have seen on the video clip, that the level service F is bumper to bumper congestion. right? Okay, so, and later on, they talked about the use of level service. What is the problem about how to use this? If you notice that the term of level service is rather hard to understand, because you would need to see a little bit closer of how to define the level service. And the level service of freeway segment, of multi-lane segment, of intersection, whatsoever, of the ramp, they are totally different too. So I give you a head up why it's a problem, okay? So type of uninterrupted flow facilities. I think you have seen on the YouTube earlier already, okay? Anyway, in this chapter, they talked about, we're gonna discuss about uninterrupted flow. If you imagine uninterrupted, in Thai mean ไม่มีผลกระทบใช่ไหมครับไม่มีการกระทบกระทั่งแสดงว่าถนนนี้ถูก control ถูกไหมครับ so the full control, that means there's no accesses from the side of the road. The road is controlled by, you know, the right of way, which cannot be accessed directly. To be accessed, the only, you know, facilities that allow include ramp, you know, interchanges, that kind of thing. But at some part of the highway segments, okay, freeway fully controlled, highway some control, but at some portion of the highways where there's no access or no intersection, it's just, you know, long corridor, it could act as uninterrupted flow too, okay? So when we talk about uninterrupted flow facilities, you need to think of where we are talking to. In HCM or highway capacity manual, is talked about how much traffic a given facility can accommodate. This is the meaning of the capacity, okay? But the HCM has been developed in many versions. And I think the version on the clip that you just saw was 1985, okay? On the 1985, the one that we saw, okay? But the one that we study is 2010, okay? It's 2010, and it hasn't been edited again. I heard that they were updating on some chapters, especially things that involve with autonomous vehicles, okay? Autonomous vehicles, I think some of you may already learned about, you know, cars that drive by themselves. Many projects in China, in America, in Singapore, or in, you know, South Korea, they started doing this type of vehicles in commercial mode, but they haven't done into the highest level, which is fully autonomous. Someone has to be behind the steering wheel, but the car can move without touching the wheel. I think this area is quite challenging. In many developed countries, I think they kind of exciting about using it because the benefit of using this kind of vehicles, they have performed that it's got the reduction of the number of crashes, because human has the ability to kind of get some errors. Okay, just hello ได้ยินไหมครับ
ดี
โอเคครับ on if you study about what causes of the accidents, human being has caused many errors, and such as sleeping on the wheel, driving tirelessly, using cell phone whatsoever is contribute to the number of crashes. Many car manufacturers try to, reduce this kind of error by having motor itself to drive by its own. So you just give the origin destination and it can go along the road by reading through signs, pavement markings, and many sensors involved. So the new possible new chapters will include some of these too. What you have learned here, I think it developed for a long time ago. And when I was in the United States, I've been using the version 1997. And I look at 2010 version, just some part that has changed, especially ITS, Intelligent Transportation System. They included in this version a lot. We are in the digital age already, so definitely things have changed. Okay. The software, many softwares can be helpful for you to analyze not only for the operations but also on the design part. Okay, when we talk about design, we need some basic elements to add into your design diagrams. And when you use HCM software, I think actually it's called HCH. Okay, HCS. HCS is the developed by Metrans to do all this. On the left, I think this is interrupted flow. Okay, on the left here, street signal, yeah, transit interchange, two-way stop sign, always stop sign, roundabout, pedestrian and bike. Okay, warrant, data. This one I don't get it. On this side, on the right side, mostly this is the uninterrupted facilities. Okay, until multi-lane, two ways. This one is the spatial now. This is two-lane highways. Okay, but those who are interested in using this software, I think I have Synchro, but it's not HCS. Synchro is more advanced than HCS software. It can also simulate the traffic while you're doing the job by putting the geometric number of lanes, traffic volumes, that kind of thing. You can get simulation right off the input that you get, so you can see what the level service is right after you input the parameters. And more advanced software is AIMSUN, for example, AIMSUN, AIMSUN, okay? Or the other one, VISIM, VISSIM. Those two types of software has been widely used around the world now. If you are working in a consultant firm, you gonna, I think, unavoidable to use it, which I think is a great opportunity to try. But anyhow, some of the basic that you're going to learn here will be useful when you try to input those parameters in the software. Okay. The concept of the capacity stated here. The capacity of a facility is the maximum hourly rate, okay, at which persons or vehicles can be reasonably expected to traverse a point or uniform segment of a lane or roadway during a given period of time under prevailing roadway traffic and control condition. Okay. The last, oops. Somebody call me. I think we'll stop a little bit for here. Sorry for interruption. Share screen again. Okay. So they break into different parts so that this phrase has this sentence has several sections, several parts that you should consider. Okay, I think the last part here is easy. Okay, under prevailing roadway traffic and control condition, it's giving here traffic, roadway, and control. So along the clip, remember, they stated about 12-foot lane, how many lanes in the one direction, road users are familiar with the facilities, those kind of things. Okay. Can you hear me? Okay, sorry, I forgot to turn on the speaker. So as those prevailing conditions require to be met. If it's not met, what is gonna be? So the ideal condition will be affected by those parameters. So it's giving the idea that if it's not 12-foot lane, like 10-foot lane, the speed will be lower. Once the speed lower, the traffic flow will not reach the maximum capacity. That is the effect of the lane geometry. Okay. Reasonably expected, some regularity expected, like capacity is not a fixed value. Of course, it's not a fixed value. It depends, vary by areas too. If you understand 2-lane highways, 4-lane highways, 6-lane highway, 10-lane highways, there will be different capacity. And on a 4-lane highway or a 6-lane highway, the condition may be different. Okay. And the 6-lane highways of particular locations compared to the other may be totally not the same too. So anyhow, for the designer, we expect it to be the same. Okay. Transferred at a point of uniform section. So if you change the point of the consideration, it changes the capacity too, if the condition is not the same. When we talk about counting the traffic, we will usually divide 1 hour into 4 slots. Each slot will be 15 minutes. Okay. For example, from 4 p.m. to 5 p.m., we will start counting from 4 to 4:15, and then 4:16 to 4:30, 4:31 to 4:45, and 4:46 to 5 p.m. But this is example. And each 15 minutes, you count the number of vehicles that passing through a point. Okay, you record it, and each 15 minutes, you will find that it's not the same number. Okay. Anyhow, the uniformity, if all 4 are equivalent, okay, when you count, is maybe just a few vehicles different, it's uniform. That means the condition of traffic perhaps very congested all hour. Okay, or maybe there's no traffic, it's just few cars, but cars that move past through the section are uniform. Okay, but if you compare to a road section that may have a different, volumes on each if 15 minutes, if like, for example, 4 to 4:15, 4:1 to 4:15, 100 cars passing. 4:16 to 4:30, 200 cars passing. 4:31 to 4:45, 500 car passing. And 4:46 to 5 o'clock, 300 cars. So the slot between 4:31 to 4:45 is kind of peak. That means that is the worst 15-minute period. So we analyze that, and we will see that flow is showing that it's starting to get more vehicles demand passing through that intersection, passing through that section. So anyway, it's hard to explain. If you see some examples, you will understand more. Okay. This slide saying the difference between capacities of each type of facility. In 2010 SCM, the free flow speed is defined for freeway above 70 miles per hour, 65 miles per hour, 60 and 55. Okay. The capacity of freeway under ideal condition, okay, is 2,400 passenger car per hour per lane. Okay. Passenger car per hour per lane. And if you notice that if the speed is reduced, capacity getting lower too. Okay. For multi-lane highways, the free flow speed of greater than 60 miles per hour is 2,200 passenger car per hour per lane. And lower and lower. I think this number should be 45. I think this one is wrong. Okay. Two-lane highways for all speed is ideal condition is 3,200 passenger per hour for both direction. Both direction. And the maximum, if you consider it could be 1,700 passenger car per hour, just one direction. Okay. The level service concept and the service flow rate. Okay. As you get some idea from the video clip that you see the level service A, C, and F, right? You can get some conditioned from the photo from the graphic already. So if we talk about level service A is the best condition and F is the worst on the system breakdown. If under service A is a free flow, okay, service flow rate is at SFA. Level service B, reasonably free flow, maybe more cars, but you can drive at the free flow speed, which is here. When we talk about free flow speed, is a speed to make you understand easily, is speed that you feel comfortable driving, you know, along the road without the impact or effect of other cars around you. Okay. If the posted speed is 60 miles per hour, you still drive at 60 miles per hour with confidence and not feeling that car around you, you know, driving and affecting your performance or affecting your behavior. If there are more cars, of course, cars around you get some impact to your decision. Whether you see the braking light on, so you have to step on your braking rather than on the acceleration pedal. That is the impact of the surrounding vehicles. So the free flow speed has the meaning for that to let you get more idea. Okay. So even on the level service C, the stable flow, okay, is the flow that's still, you know, going very well. And the level service D, approaching unstable flow. So this is become like part of the, just like, Okay. There we are now. Okay. Okay, so level service E becomes like unstable flow, and F is a fast flow. Let's see what we have here. Screen. This graphic, okay, is the showing the relationship between speed and the flow rate. Okay. Under this group, the first group, this is under saturated flow. Okay. When we talk about free flow speed is 70 miles per hour. Okay. So the flow is kind of stable. Okay. And increasing a little more, and the flow rate starting get more and more. Okay. Until this area is become the maximum flow rate. Okay, maximum flow rate 2000 something right here. Beyond this, the speed will drop and is get into oversaturated flow. Okay, the area here causing the traffic jam where the level service F is expected. Okay. So go to it's necessary to see this, otherwise it's not gonna be easy to understand. Okay. If you see those graphics that I show you in previous chapter, this part is the top one. Okay, it's the top one. Is the top part. Okay, free flow speed at 75 miles per hour. This line, the one that we compare 70 miles per hour is this line. Okay, before it's reaching this area, before it's breakdown. Okay, it's a level service what F, right? The density is 45 passenger car per mile per lane. Beyond this is level service F, and the flow of traffic go back to here. Okay, this part didn't show the behavior over here, but the graphic earlier I show you shows the behavior of the condition of the traffic jam on level service F. And this maximum flow rate we expected when the traffic start getting, to level service F will change from free flow speed to a little bit drop to about 55 miles per hour of the free flow speed, 70 miles per hour here. Okay, to here. So this is about 55, right? Okay, yeah, but it giving you the maximum flow rate over here. Okay. Mhm. And this graphic is different from this one. This one is for freeway. Okay, freeway. This one is for multi-lane highways. Okay. When you study, it has a slightly different capacity. That's why you meet the level service at, I'm sorry, the capacity of free flow speed at 60 at 2200 passenger car per hour per lane right here. And dropped after, free flow speed or posted speed is lower. Okay. The equation of the graph can be computed using these equations. But I don't want you to, remember all of this, but I just, the equation, I just want you to understand the differences between level service of different facilities and the meaning of capacity. That's more important. Okay. At this point, anybody didn't understand? Everyone understand?
เข้าใจครับ
ขอบคุณครับ Okay. So come back to the slide that we just stopped. SF multiplied by PHF. Okay, PHF stand for peak hour factor. Okay, peak hour factor is equivalent to the total volume per hour divided by 4 times maximum 15 minutes of that hour. My pen is not working. I will find the definition for you later. I usually be able to write on my screen, but my pen just lost my battery. Okay. Anyhow, okay. This slide giving you a kind of the map of what you can look for if you're interested in measure of effectiveness. Okay, MOE stands for measure of effectiveness in highway capacity manual. You can find from these chapters. It's kind of index. If you don't understand how do you get the idea of how to for example, in terms of operation, if you talk about freeway, what kind of measure of effectiveness should you use? You're going to use density, or you're going to use speed, or you're going to use something else. Okay. This table showing some of the summary, like freeway facility. They use density for the measure of effectiveness. Density can transform into level service too, right? Because you, on the graphic earlier, we see that the density is not is in the table. Just I want to show you that one again. Yeah. So you see the density. This is density, okay? 11 passenger car per mile per lane. This is density. Think of 1 mile in 1 lane. There are 11 passenger cars fit in it. But if it's 18 passenger cars, then it's fall in level service B. Okay, this is density. The criteria here is the density. That's why you see the comparison. Oops. Right here, okay. Okay, signal delay, okay, vehicle delays, not passing. 2-lane highway, person time spent following the truck, right? The YouTube also mentioned about platoon. Remember platooning? The definition of platooning. I don't know if you get that word or not, but you should go back and find out what the meaning of platooning. Okay, platoon, P-L-A-T-O-N, platoon. If you were driving in the rural area, you would quite understand this condition a lot. When you followed a slower traffic, especially a truck, there may be accumulation of vehicles ahead of us, 4 to 5 cars following just one truck. And you need to find a gap to be able to pass safely on a 2-lane road. One car, first car go first, second car after, or maybe 1, 2, 3 cars go at the same time. But with this condition, you understand that it impacts a lot to the capacity of the road and also the safety in terms of you need to find, a suitable situation for you to pass safely. Some who do not obey the traffic laws very well will, result in very serious injury or damage to the car, especially passing at curbs. So the design of the geometry on the two-lane highways is important to identify where should they start to pass or they shouldn't pass. Vertical curves, you will see, when we have a stack curve and a crest curve. A crest is like this, right? So at the crest curve, you cannot see oncoming traffic behind the hill. So along the road, engineer need to pave a double strips on the median. It's not a dashed line, so it must be solid line on both, so they cannot crossing over the hill. But if it's a stack curve, okay, you allow something like this. Should not be neglected when you design a comprehensive section of the road. Vertical alignment, horizontal alignment, signs, pavement markings, and so on. Road lighting is also important. There's another course for road lighting design. You know, this will be very, very good for someone who, you know, try to make the city, you know, planning look great too, because we do not just only design good lighting for vehicles, but also pedestrians and, you know, atmosphere for the city. You know, is a very interesting subject in my opinion. Roadway lighting. Okay, some part is too bright. When it's too bright, you cannot see well on particular situation. The color of the lighting also impact to the decision you make. Yellow color, yellowish color, you see only one color at night. The subject, when you know, have the reflection of the yellow color, you cannot classify very well what materials color should be. But if we use the LED daylight lighting instead of the yellow one, you can see the objects clearer, and you can identify the color of the object too. Something like this is going to be very useful for many other areas, such as, for example, when police want to track any you know, kind of situations, like, for example, stolen vehicle. If the victim said that, okay, my car got stolen, it's a white car, it's a Corona white car, for example, the license plate number, if it was at night that got stolen and passing through the area where, you know, we use the high pressure sodium, which giving you the yellow lighting, you cannot really identify whether this is a yellow car or this is a white car. But if you use the LED with the color temperature close to daylight, then you can be able to identify with your naked eye whether this is the white or yellow. Something like this is going to be very helpful for tracking, you know, motor vehicles that got stolen or some crime that happened nowadays. So yeah, I give you the idea of you know, out of the box. What about technology nowadays that changed how we design? Okay, so yeah, this is a summary for this one. Okay, VOC, and it's used in capacity analysis. VOC, rate of flow, and the capacity. So the capacity is the unit, okay? And you can see that there are varies. When you compare, you have to think of several conditions. Okay. Here is going to explain. The comparison of true demand flows to capacity is the principal objective of capacity and level service analysis. Okay. The volume capacity ratio indicates the proportion of facilities capacity being utilized by the current or projected traffic. Okay. Used as a measure of the sufficiency of existing or proposed capacity. For example, an existing roadway is a 4-lane highway. If you go back to the 4-lane highway it's showing here, if it's like driving at 50, allow you to allow this section of the road is 50 miles per hour. A 4-lane highway can give you a 8,000 passenger car per hour per lane, right? For the maximum capacity. One, during a peak hour flow in the evening, 4 to 5 p.m., the capacity may be reached, and the flow of traffic look like it's less than capacity because the traffic is jammed. When the traffic is jammed, you notice that the flow cannot exceed the capacity, right? So, but if you know the other one, which is the speed, you will get it right away whether the V over C is what is at where, compared to the same V over C when the speed is high at almost 50 miles per hour. Volume, free flow, the car can flow, but there are not many cars. You know, the condition of the road is good, levels with C or D, that show that it's the same VOC too. So it's giving you the idea that when you compare it, you need to also give to the right measurement of the speed here, whether it's above or it's below. Okay. V over C is usually less than or equal to 1. Okay. If V is equivalent to C, is 1. However, if a projected rate of flow is used, that means if you are going to propose a future corridor, what you're gonna do with this corridor, like expansion, you may expect the one that higher, the VOC that greater than 1, because the demand volume is higher than the capacity. Okay, so just one condition. If you are going to propose the future, then the demand can become much more than the existing volume, and it could be greater than capacity. So on other conditions, VOC should not be greater than 1. Okay. Yeah, here, a VOC above 1 predicts that the planned design facility will operationally fail. Queue will form. Okay. Yeah, it's already happened in Bangkok. Okay. All right. So what time is it? Almost 8 o'clock. I will stop here at this chapter, and I'm gonna continue again on Thursday with the other slide and maybe a little more of other materials. If you don't understand, you can call or ask me, or you can go and look at the materials, which is this one, textbook, traffic engineering, this one. Okay. Yeah, because I want you to be able to calculate a little bit at the some of the example here. Okay, the HF peak hour factor right here. Yeah. We will come back on Thursday and look through all this, and so you can get the idea of how you can calculate the level service or even the design analysis. How many lanes should you accommodate? You know, the number of vehicles in the future if you were a designer to make this road at the level service at a certain level service. Okay, at this point, any questions? Nope, no questions. I feel like when I talk alone, I'm so lonely.
โนครับอาจารย์
ขอบคุณครับ
โนครับ
ผมก็เรียนอยู่นะ เวลาเรียนเนี่ยที่สถาบันพระปกเกล้าผมก็รู้สึกว่าเวลาที่อาจารย์เขาสอนผ่านซูมเนี่ยหลายท่านก็บอกว่าโอ้ยไม่เหมือนสอนที่คลาสเลย ผมก็บอกว่าผมเข้าใจอาจารย์เลยครับ เพราะว่าตอนผมสอนซูมผมก็รู้สึกอย่างนั้นไม่รู้สึก human touch เลยหลายคนผมไปสอนอย่างที่ธรรมศาสตร์ในห้องอย่างเงี้ยมีความรู้สึกว่าถ้าไม่เข้าใจมองตาแล้วก็รู้แล้วเข้าใจไหมเนี่ยเนาะโอเคขออนุญาตทุกท่านเปิดกล้องด้วยครับเช็คชื่อหน่อย
อาจารย์ครับพอดีวันนี้อ้อใน PC มันไม่มีกล้องเป็นไรไหมครับ
PC ไม่มีกล้องเหรอครับไม่เป็นไรครับแต่วันนี้มาเมื่อกี้เห็น24 คนตอนนี้เหลือ23ไม่แน่ใจหายไปไหนคนลืมถ่ายรูปเลยอ๋อเรามีเรคคอร์ดอยู่แล้วจะถ่ายรูปอีกทีนะครับเปิดกล้องให้หมดด้วยครับเดี๋ยวถ่ายรูปนิดนึงท่านใดไม่มีกล้องก็แจ้งให้ผมทราบด้วยแล้วกันเมื่อกี้แจ้งมาแล้วท่านหนึ่งพวกเราคิดถ้าพวกเรานี่คิดจะฉีดวัคซีนกันไหมครับถ้าเขาเปิดได้ฉีดนะครับ
เดี๋ยวรอคนอื่นฉีดก่อนครับ
รอคนอื่นฉีดใช่ไหมครับ
ผมไม่ได้ฉีดครับ
เจอบัตรแล้ว
ผมฉีดแล้วนะครับ
อาจารย์ฉีดแล้วเหรอครับ
ใช่ครับ วันนี้เข็มที่2ครับ
ฉีดวัคซีนอะไรครับอาจารย์
ซิโนแวคครับ
อ๋อ มีผลข้างเคียงป่ะครับ
ไม่มีเลยครับ วันครั้งเข็ม1นี้รู้สึกปวดแขน วันนี้ไม่รู้สึกอะไรเลย
เยี่ยมครับ
ผมมองว่าอะไรก็ดีนะตอนเนี้ยวัคซีนตัวไหน
ดีกว่า
ก็
ไม่
ได้
ฉีดใช่ป่ะ
ดีกว่าไม่ฉีด คือถามว่าต้องฉีดอีกไหมปีหน้าผมว่าปีหน้าก็ต้องฉีดอีกมันมี variance เนาะแล้วก็
อาจารย์เปิดแล้วผมคงต้องตามครับ
อาจารย์วินัยก็ฉีดนะครับ หลายๆคนก็ฉีด ผมว่าอย่ากลัวมาก อย่าไปกลัวมากกลัวว่าถ้าเราเป็นหนักเนี่ยน่ากลัวกว่าถ้าผมเห็นที่เขาแบบไม่สามารถช่วยได้อย่างเงี้ยโอ้โหน่าสงสารแล้วเพื่อนฝูงนี่จะรังเกียจมากเลยนะงั้นผมมองว่าพวกเราถ้ามีโอกาสเนาะเดี๋ยวเขาคงเร่งสปีดให้เร็วกว่านี้อ้าว เชิญท่านแรกนะครับเศรษฐโรจน์
ครับอาจารย์
ชั
เมื่
ด
อกี้
เจน
บอกว่า
นะครับ
ไม่มีกล้องใช่ครับ
โอเคศิลานัทธนิต
ครับผม
ครับขอบคุณครับ กันพิเศษ
มาครับ
ขอบคุณครับ ปรมาพร
มาค่ะ
ขอบคุณครับศิวพรจุลจิต
มาครับ
ขอบคุณครับ พิชยะ ไม่มาเหรอครับ พิชยะ ชัยกฤษ
มาครับ
ขอบคุณครับ ปิติชัย สิทธิพล
มาครับ
ขอบคุณครับ ธนพล
มาครับ
ขอบคุณครับ วัชรฤทธิ์
มาครับ
ขอบคุณครับ วริศรา
มาค่ะ
ขอบคุณครับฮารุณา
มาค่ะอาจารย์
โอเค ธัญชน
มาค่ะ
ขอบคุณครับ วัชรพล
มาครับ
ขอบคุณครับ นัทพัฒน์
มาครับ
ขอบคุณครับ พิชพัฒน์
มาค่ะ มาค่ะอาจารย์
ขอบคุณครับ โอเค พานุพงศ์
มาครับอาจารย์
ขอบคุณครับ ภพพร
มา
ส
ครับ มาครับ
โอเค สัญญพงศ์
ครับ
ขอบคุณครับ ซิมิลัน
มาครับ
ขอบคุณครับ สุกฤต
มาครับ
ขอบคุณครับ ห้วน
มาครับ
สาริยา
มาค่ะ
ขอบคุณครับ โอเค เจอ
อาจาร
กั
ย์
น
ครับ
วันครับ
อาจารย์ครับ เมื่อกี้พิชยาไปเข้าห้องน้ำครับ
โอเค โอเคครับ ขอบคุณครับทุกท่าน เจอกันวันพฤหัสเวลาประมาณนี้นะ แต่ถ้ามีอะไรเปลี่ยนแปลงผมแจ้งอีกทีนะครับ
ขอบคุณครับ
ได้ค่ะอาจารย์สวัสดีค่ะ
ขอบคุณครับ สวัสดีครับ ขอให้โชคดี
สวัสดี
ค
ครั
รับ
บ
ครับ
สวัสดีครับ